Alright, so this is an analysis of the Wizard of Oz problem and then CodeForces round 695 division 2. So, there are n total digital panels in a straight line. They can show any digit from 0 to 9, but they initially all show 0. So every second, the digit is increased by 1, such that if it was a 1, it would be a 2, 2, 3. But if it was also a 9, it would revert back to a 0. But when a panel is paused, that digit remains constant regardless of how many time passes. So if you pause it at 6, it will just stay at 6. And once you pause a panel, the adjacent ones to those are paused 1 second later. So if you pause the first panel, the second panel gets paused 1 second later. The third panel gets paused 1 second after that. So 2 seconds after the first one. The fourth one gets paused 3 seconds after the first one. The fifth one gets paused 4 seconds after the first one, and so on. And so you're trying to figure out if there are n total panels, what is the largest number you can get by pausing one of the panels at the optimum time. So first line contains test integers, and each line contains a single integer n representing how many panels there are. So let's say, for instance, n is equal to 4. Right. Now there are 4 total panels, and you're trying to find the maximum possible value that you can get from pausing just one of them. So here's an example of, let's say you pause the second one at 3, right? So this one becomes 3. Now the ones next to it would be 3, but would only be paused the next second. So the ones next to it would be 4, 4, and then this one would be 5. So obviously this one isn't the optimal number, but you can see just by pausing this one at when 1 is equal to 3, this is the number you would obtain. Likewise, let's say you pause the last digit at 6. So right, this is 6. The adjacent ones will be paused 1 second later. 7, 8, and 9. So you can see this is close to an optimal number, but it isn't exactly optimal. And thus, you can see this is what happens when you pause the last number at 6 of the 4-digit number. So what would be an optimal number? Just manually computing it. So let's say you have 1 digit, right? The optimal number would just be 9. That's obvious. 2 digits, so 0, 0, 0. The optimal, you can't go for 9, 9. That doesn't work, because you can't pause 2 at the same time. So you're left with it being 9 and 8. So that would be the optimal for 2 digits. Let's carry on. 3 digits. Now, the logical, people might think, right, it would just be 9, 8, 7. But instead, what you could do is, instead of pausing the first digit, the third digit, you could pause the second digit at 8. So by pausing the second digit at 8, the new number you get is 989, which is more optimal than 987. And so you can see, once you keep going to more digits, the optimal number just remains by pausing the second digit. So in this case, it would be 9890. 98901. And keep going. So you can see the optimal way to get the highest digit number would just be to pause the second digit at 8. And so how would you do that in code? So here is a Java solution to that number and to the equation. So first, read in the total test cases. Then for each test case, you read in the initial number. And so you can see in all of the cases, the first digit is always a 9. 9, 8. And then it keeps repeating from there on. Not repeating, continuing from there on. So that's why initially I give them print the 9, because 9 will always be the first digit. And then for all, continuing from there, you would just keep on continuing from 8, 9, 1, 0, 2, 3, 4, and so on. So that's essentially what you can do. But one crucial thing you can remember is you can't store the number you get in one variable, because that variable could be 2 to the power of 10, 2 times 10 to the power of 5 length long, and that would take too much time to run the whole program. It's going to involve 1 second time limit. So yeah, after you obtain a number, you just still have to print it on the same line without storing it. And then essentially, yeah, that's how you can do this problem.